Hi, I'm Julia Mack, and I am doing problem 25 from WebWork9. I wrote this out once, so I'm going to pick it up with my handwriting in the second half, but let me explain through the first part. So we're given, suppose f of x, y is equal to x over y at point -2, -3, sorry. And the direction vector v equals -4i minus 4j. To find our gradient vector, we need to take the partial with respect to x first, then the partial with respect to y at I and j, respectively, as you can see here. So first let's find the partial with respect to x. F of xy is given as x over y. So the y just comes along for the ride, and we're given 1 over y with our partial with respect to x. Now our partial with respect to y, the y is basically y to the -1st power. So we'll take that -1 out front, and we're left with negative x over y squared. So our gradient vector here is gradient vector f of xy is equal to 1 over yi minus x over y squared j. Okay. So now it wants us to find it at point P, which is -2, -3. So putting that in, we have 1 over -3 for I minus a -2 over -3 squared j, which gives us our gradient vector f at -2, -3 equals -1/3 I plus 2/9 j. Okay, and then the next part, it wants us to find the directional derivative of f at point P in the direction of v. So the directional derivative of f of xy is given by the gradient vector, which we already found, and the dot product with the unit vector of our directional vector v. So first we need to find the unit vector of v. So we'll take the magnitude of v. We have 4 squared plus 4 squared is the square root of 32, which we can simplify to 4 root 2. Again, since we're taking the unit vector, we'll label it u now, of the vector v over the magnitude of v. So we have -4 over 4 root 2 I minus 4 over 4 root 2 j. So our unit vector is equal to -√2 over 2i minus -2 over 2j, and how I found that was simple, of course, taking out the 4's, they cancel each other out, and then rationalizing the root 2 from the bottom, bringing it to the top. Okay, so that was just our first step. Now we need to take the dot product of those two to get the direction vector. So we have, we'll take it from the gradient vector, 1 over y multiplied by -√2 over 2 minus x over y squared multiplied again by -√2 over 2. This gives us our direction vector as -√2 over 2y, and we have a plus √2x over 2y squared. Okay, now it wants us to find this. This is where I'll be picking up. It wants us to find the directional derivative of f at the point P. So we found our directional derivative, and let's find it for the point P. So we have the directional derivative of f of xy at u is -√2. Oops. And since, sorry, we're finding this for our point -2, -3. So we'll put in 2, and our y is a -3 plus a √2 -2 over 2 times a -3 squared. Okay, so simplifying, we have the negatives will cancel out. We have a root 2, a positive root 2 over 6, and this will be a -2 root 2 over, it'll be 2 times 9 over 18. Okay, now we need to put these fractions so that we can simplify it. So this will be multiply the top and bottom by 3. 3 root 2 oops, sorry, 3 root 2, not 3, over 18 minus 2 root 2 over 18 gives us the final answer for our directional derivative at the point P, negative 2, negative 3, is equal to root 2 over 18. Okay. The next part of the problem is asking us to find the maximum rate of change of f at P. Okay, so the maximum rate of change is the magnitude of our directional derivative. So the directional derivative which we found, again, was here. Our directional derivative, d of u, f of xy equals negative root 2 2y plus root 2x over 2y squared. Wait a minute. I'm sorry, it's the magnitude of the gradient. Oh my goodness. Okay, we're taking the magnitude of the gradient at that point, which we did find. Magnitude at the point, the gradient at the point negative 2, negative 3 is negative 1/3 I plus 2/9 j. So to find the magnitude of that, we'll take the square root of 1/3 squared plus 2/9 squared, which equals the square root of 1/9 plus 4 over 81 equals square root of 9 over 81. Oops, 81. Oh boy, plus 4 over 81 equals square root of 13 over 81, which we can simplify, of course. So we find that the magnitude, or the maximum rate of change of f at point P, negative 2, negative 3, is equal to the square root of 13 over 9. The final part, part E, is to find the unit direction vector at which the maximum rate of change occurs at P. So that'll be taking our gradient vector here over the magnitude we just found. So that's simple enough. Gradient vector at the point negative 2, negative 3 over the magnitude of the gradient vector at negative 2, negative 3 is equal to, and let's do it this way. We'll write negative 1/3 and swapping this over, 9 over root 13 I plus, let's see, what do we have here? 2/9. Again, 9 over 13, since we're really dividing it by the root 13 over 9. J. Okay, let's simplify this. This cancels out. We have negative 3 over root 13 I. The 9's cancel out here again. Plus 2 over root 13 j. And we'll just rationalize this. Our final answer is negative 3 root 13 over 13 I plus 2 root 13 over 13j. Okay. And now we'll just quickly plug in all our answers into the WebWork, make sure everything's correct. So going here, we found that the gradient vector was 1 over yi plus a negative x over y squared. We found that it was a negative 1/3i plus 2/9 j was the gradient at point P. Our directional derivative, we got at point P, yes, the square root of 2/18. The maximum rate of change, we had the square root of 13/9. And our final answer here, we had -3 square root of 13/13 I plus 2 square root of 13/13 j. Checking answers. All correct. Love to see that. Thanks, everyone.